Right, so what is a linear equation? What does that mean? You know what that means?
It's like an equation of a line.
All right, what's the equation of a line?
Is it like y equals mx plus b?
Mm-hmm. So y equals mx plus b. And that is what's called, you know what form that's called?
Isn't there like standard and there's
Yeah,
I don't know what the other one is.
slope intercept. There's standard, you're right. What is standard form?
It's like ax plus bx or something.
Mm-hmm. I think it's ax plus by equals c. Pretty sure that's it. That's standard form. I like to think of it as stupid form because it's pointless. You get nothing out of it. You don't get the slope. I guess you maybe get you don't really get the y-intercept. What do you do with it? You put it into slope-intercept form is what you do with it. So the other one, although when you do like a system of linear equations, they're written in standard form typically. When you have one on top of the other, you often see them written like that. The other one is point slope form. All right, point slope form. What's point slope form? It is y minus y1 equals m times x minus x1.
Oh, I've never learned that.
No? Okay, so point slope form is not super common. This is the big one. But this one is fair game for the test. It's an X. All right, but right now we're going to start with this one right here. All right, so all right. So if I have an equation like 3, not a 3, y equals 2, y equals 2 over 3x plus 1. Do you know how to graph that?
It's like 2 up and 3 right.
So like 2 up, 3 right, like right here, something like that?
No, from 1.
Good.
Just one's the y-intercept.
Yeah, one's the y-intercept. So you start from here.
Yeah.
Right? Okay. Then up 2, because that's your rise. All right. Up 2 and then over 3. 1, 2, 3. All right. And then you connect your dots. Right?
Mm-hmm.
You said you didn't know this one. Sounds like you know it. Okay. I've gone this far with the arrow. I'm committed to make it look like a regular arrow. All right. So we'll go over here. There. All right. So, well, I got this point right here. I got this point right here. What's the slope of this line?
2 over 3.
2 over 3. What letter represents slope?
M.
M. So I'm going to just make up a random point off the top of my head. I'll say point A is 0, 1. And point B is 3, 3. How do you find the slope?
You do it's like y minus y1 over x minus x1.
Okay, so M equals y minus y1 over m minus, wait, what did you say?
X minus
x1. How come it's not x minus x1 over y minus y1? How come it's the y on top?
because it's rise over run.
Yeah, rise over run. Cool. And so how should we do that with this? Should we label our things? So how do we do it with these points right here? How do I get the slope of the line that contains these points?
So you should put the y values in the top.
Okay, so Like that?
Yeah.
All right, what do I write?
That's y, and then the other one's y1.
Okay, that's cool. Oh, and this is wrong. It's actually y2 minus y1 over x2 minus x. But it'll work the way you did it.
Okay.
But we were thinking of that because of this up here.
Yeah.
And it's the same equation, actually. It's the exact same equation. This equation, if you do a little bit of algebra, this one here, is actually this equation. Same thing. Okay. All right, so now what? So, okay, so make that y2, right? Make that y1. Now what's this over here?
x2.
Okay, that's over here.
x1.
Cool. So what's the slope? No, like, I want to see the work.
Oh, so basically it's a 1 minus 3
1 minus 3 over...
over 0 minus 3.
All right, which is...
2 over 3.
Is it on top I get 2? Wait a minute.
It's negative 2.
Negative 2,
Negative 3.
which is
2 over 3.
2 over 3. All right. Do you know what? And so like, that's our guy right here, right? Bam. So in a word problem, you get a problem that says John. John charges for his photography business. John charges a setup fee of $300 and an hourly rate of $50 per hour. Write equation that represents this, and I'll just do that. Write equation that represents this, and then that's like first thing that we're doing, and then the second thing that we're going to do is how much does the customer pay if John works 2.75 hours. We'll say he charges every 15 minutes.
He charges every 15 minutes?
Yeah. That's why this will make sense. So you're not gonna have to you don't have to make it 3 hours. Like you can just use a decimal in the problem.
But you said it's an hourly rate, right?
Mm-hmm.
You use a calculator.
Well, you first have to write the equation. And then you use that equation to get the second part.
Okay, so the equation is 300 times 300 plus 50x.
Okay. Cool. So the way that, and that's basically it. But what they want is they want this. They want y. Technically, they want this. He does this a lot. Well, actually, I'll do it the first way. So y equals 50x plus 300. But you'll see stuff like this all the time, like charge equals 50h plus 300. That's the hours. That's how much you charge. Right? All right. So now that we know that, how do we solve this problem?
You should put 50 times 2.75 plus 300.
That's right. All right, so what does that work out to be?
$437.5.
0.75 plus 300 is how much?
$437.5.
Okay. So if you have a graph like this, and we'll say this is Steve's income. Steve's income since he graduated college. Graduated college. By the way, my sentence is grammatically incorrect. Graduated from college. If you graduate college, I had a parent tell me this. He's like, my pet peeve is when people use grammar incorrect, graduated incorrectly. He's like, if you want to graduate college, that means you pull right up next to a college. You help, and then you go with your hands, and you go 1 foot, 2 foot, 3 foot, 4 foot, 5 foot, 6 foot. You're graduating college. Like a graduated cylinder, you're saying the different measurements going up. That's graduating college. You graduate from college. Okay. All right, so here's the income. It's going to be like that. And let's say this is, well, first of all, let's just look at that. Something should be kind of odd about this. Is something kind of weird about this?
How?
Well, I'll label the axis. So I'm going to say this is, I'll say this is 1 year, right? And then every 2, so that's, well, actually, fine. 2 years, 3 years, 4 years. All right, so that's really sloppy. It's what, and this is money. This is dollars on this side. So I didn't give you any dollar amounts, but something should still strike you as kind of weird.
There's no dollar amount.
No. What else?
Doesn't go through the origin.
That's kind of interesting, I guess. All right, so let's say it was like this. What does that mean?
It's just exponential increase.
Exponential increase would be like this, right? So it's still linear. The blue one's linear. The green one's linear. But this means that at year 0, year 0 is basically Steve holding a diploma with a cap and gown, and he doesn't make any money at all. He makes 0 money, right? So that's year 0. And so the College Board often asks you to interpret the y-intercept. That's often on a test.
So like the first second you make money.
Huh?
So it's like saying like the first second you leave college you make money already.
Yeah. That's right. Or if you can plot it, maybe you're plotting it. So the only data point I have is this one. The next data point I have is this one. The next data point, and then I connected the dots, right? So we just kind of keeping track every year. But we started with the first year, and how much does Steve make on the blue graph? I'm sorry, we started on the 0th year. Like, congratulations on graduating college. How much money you make?
0.
0. This other situation.
Oh, you make negative money.
Steve's got some problems. Maybe he's got some people after him. Because he's negative money, but he is getting himself out of a hole, right? So he's like, maybe he got himself a job at McDonald's, and so he graduated college, and he's like, all right. Actually, what's interesting is he did get himself a job at McDonald's because he never got a raise ever.
What?
Right? So like,
because
actually no. If you think of it as cumulative, dollars. But if you think of it as like your, hold on, let me think. You can think of it as your, in both scenarios, there's no raise. It's the same hourly rate.
Because they have one slope.
Yeah. So it's like the income. So it's actually, no. Forget what the other guy just said. He's totally getting raises. He's getting constantly the same raise all the time. That's what it is. So his income is increasing by the same rate every year.
Oh yeah, that's why he's earning more and more.
Yeah, he's earning more. So this isn't his bank account. This is like his how much at the end of the year he says, "Woohoo! I made 50,000," and the next year, "Woohoo! I made 55,000." Next year, "Woohoo!" So it's always increasing by the same amount, right?
Yeah.
If which is not very exciting, but if you have like a just like a bank account, like if a person gets this, if a person earns, like if a person has a starting salary, if a starting salary, like I'm sorry, a starting bank account amount, let's say you have $5,000 in your bank account, right, and you make $20 per hour, right, and this is hours, and this is money, then your income in your bank account, so your savings will steadily increase, not exponentially, steadily, right? So that's exponential growth. Then that could be achieved by like a someone who, like I would say, like you know who Ariana Grande is.
Yeah.
Her income, she achieved exponential growth in her income. You know, she probably went from like lemonade stand, you know, a kid, to like a Disney. She was on a Disney thing or something like that, right?
Yeah.
So, you know, like a lot of times when you start off, you can make like $200,000 a year, which is really good in the normal world, but really low for like an actress.
Yeah.
And then she's getting some popularity. So Disney's got to give her some more money, right? They're like, now she's making this much money at Disney. And then renegotiate, and Disney, they got to make $1 million a year at Disney, right? And then she leaves. She's like, I want to be a singer. Boom! The next year it could be like $10 million. And then the year after that, she got paid like $4 million for Coachella. So that already like took care of all of that and way more, right? So her income graph is like bam, like that. It's not a steady increase. Okay. This is a person who gets like a consistent growth, predictable growth, a linear growth. Okay. Next. So yeah, so the take-home message for this lesson is to understand what the y-intercept means in the context of a word problem. What's the y-intercept mean in a word problem?
The y-intercept is the starting amount.
Yeah, the starting amount.
So in this case, it's 300. Not for the Steve thing, but
for yeah. In terms of this one, correct. For how much is covered? Yeah. So they gotta first pay without even working. Like he just says, "Hello, I'm John. I'm your photographer," and he's made $300 for 0 hours of work. Right? That's his fee. So he's like, "Well, I only want to hire you for 1 second. That'll be $300, please." Okay. The other thing is you want to understand what the slope means in the word problem. So the College Board likes to ask about that a lot. So let's say if you have, this is time in hours, and this is distance. All right, time in hours and distance. All right, so I could say that, man, my awesome fast car can do 100 miles per 2 hours. Is that impressive? Top speed by
So
Ferrari.
bad.
Huh?
That's so bad. It's
Why?
like 50 miles an hour.
Yeah. Video. This is kind of misleading, and we don't say stuff like that, right? But we're programmed to say miles per hour. So this means we have to translate this to 50 miles over 1 hour. All right, and that means for every, and always start with the x one, the one on the bottom. So for every hour, I can spell hour. For every hour, Steve's car goes or travels 50 miles. That's how you interpret the slope. So it could be you could see it like that. You could see it on a graph. So like it'll be like this, and this will be customer. Oh, I know. Sales and high fives. And you'll like you see that and that, and it'll just ask you to interpret the slope. All right, so the slope
2
is
over 1.
so m. All right, so m equals 2 over 1. Now interpret in words.
It's 2 high fives over 1 sale.
Nope. I mean, they probably won't say it like that. They're always going to say for every x thing, every one x thing. You see, so you could have said the slope is this, couldn't you? You could have been like, well, the slope is 1, 2, 3, 4, 4. You could have said 4 over 2, right? And then you would write for every 2 Steve gets. So every 2 what?
Every two sales, Steve gets 4 high fives.
Mm-hmm. Steve gets 4 high fives, and that would be wrong. Makes sense what you did. It's right. I mean, like, the numbers are, you're not saying something that's incorrect, but that's not how they're going to word it. Because they always want you to say it in terms of one denominator. So they don't want you to do this one. They want you to do this one.
So every 1 sale, Steve gets 2 high fives.
And they'll just say for every sale. So for every sale,
Steve gets 2 high fives.
Steve gets 2 high fives. So that's for like, how do you interpret the slope? And let's talk about parallel lines. What do you know about parallel lines?
They have the same slope.
Okay, so make up an equation.
So y equals 3 over 2.
Keep going.
X
Okay.
plus 1.
Okay. And what's an equation of a line that's parallel to that?
Y equals 3 over 2 x plus 3.
Good. They're parallel. So these 2 lines right here are parallel. All right. Now I want an equation of a line that is perpendicular to this line. The hardest thing about perpendicular is spelling the word perpendicular. I'm pretty sure that's wrong. Maybe there's an E there. I'll make it look ambiguous. Okay. Go. Do you know it?
I think.
Okay.
So I'll just use the same equation.
Okay.
Y equals
Okay.
2 x plus 1. And then the perpendicular, is it,
Oh yeah, I see what you're saying. So you're saying the first one you want to make is you can start with y is equal to 3 over 2 x plus 1, and the one that's perpendicular to it would be
y equals negative 2 over 3
mm-hmm.
x plus 1.
Sure. So those are two, they're definitely perpendicular, 100%.
Really?
Yeah. Why?
Oh, because the slope is opposite.
Yeah, so negative reciprocal slopes, right? So the equation, the types of problems you usually get, like in an algebra class, would be like they have one equation that's like y is equal to 4x plus 2, and then they'll say line, right, the equation of a line that is parallel to y equals 4x plus 2 and goes through 3 comma 5. You'll get that, like in a math class.
Isn't that the LCD? I see that. Doesn't that come up?
This will come up as an easy problem, and then they'll make it hard to be mean. So I'll show you the hard one also. So this will be like, cause the reason why this would be easy if you practice, because this is a textbook problem. There's no twists to it, but and you might get it like this. It'll be like 1 through 3 or something. But if it's like number 17, it'll probably be missing some stuff.
How would you know if it goes through 3/5? Oh, do you just plug it in?
What's that?
You just plug it in.
Plug what in?
X into X, Y into Y.
Okay. And if you did that, what would you... Wait, if you did that, what would happen? Now, if you did that, it'd be a mess. You wouldn't get anything.
It will be 5 equals 14.
Okay. All right, so we know that we have... I'll just draw the graph. So we know that we have, like, all right, we start at 2, 1, 2, and we got to go up how much?
4.
4, huh? 1, 2, 3, 4, and then over 1. So we want a line parallel to this line that goes through 3, 5. 1, 2, 3, 1, 2, 3, 4, 5. So we actually just want the equation of this line right here. You know, and if I had, we'll do that a little better. If I had a ruler and some graph paper, maybe we could find it out, actually, if it like crossed the y-intercept exactly on the corner of the grid, then you wouldn't actually have to do any math at all, right?
Yeah.
Okay, so what you want to do is you want to first say, all right, well, what do I know about parallel lines? They have the same what?
They have the same slope.
Yeah, so I'm going to I know this line has a slope of what?
4.
4. And I know this line travels through which point?
I don't know.
It travels to this point.
Oh, yeah.
3 comma 5, right? So then write your generic slope-intercept form equation. So what's just the generic one?
Y equals mx plus b.
And solve now. Plug in, so we're going to plug in 5 for y. What do we plug in for m?
You plug in 4.
4. And for x?
5. I'm at 3.
3. And then you can solve for b. All right, so we get 5 equals what?
12 plus b.
Okay, and then minus 12.
It's negative 7.
Now you can put your equation back together again. We know the slope now, and we know our b. Now we can write it like a basic equation. What is it?
Y equals 4x plus, negative 7.
So,
Minus 7.
yeah. And if we go, hold on a sec. Desmos is having some technical difficulties. We're going to have to get back to that. All right, so you know that formula? Y minus y1. Well, first of all, you know how you have m equals y2 minus y1 over x2 minus x1? On both sides, you can multiply x2 minus x1. And
move it across.
And you can go bam. And then you could do a little switcheroo on what's left over, like a whoop, and you'll end up with y2 minus y1 equals m times x2 minus x1. And then you just go ahead and erase that little 2 right there and that 2 right there. And you get your point slope form equation. That's the other one. Okay, so what's this equation called again?
Point slope.
Point slope. When do you use it? When you're given the
Point and slope.
And the slope. All right, well, my problem, I gave you a point. What's the point that I gave you?
3,
5. All right, so the point is 3, 5. What's the slope?
4.
4. So then you just plug it right in. So leave y as y. So y minus the y value of the point, which is 5, equals your m, which is what?
4.
Times x minus the x value of the same point?
3.
3. All right, that's actually like done. That's the answer. And the thing about point slope form is you can have multiple answers. You could have, so like for example, now that we know our equation, which is this is it right here, right? No, wait. Yeah, that's our equation. So I can go like this, I can go like this, I can go x, y, and say, all right, well, if x is 0, what is y?
Actually, wait, no, it's -7.
-7. All right. So that means that this point exists on the green line, right? So 0, -7. So I can go over here and say, all right, well, m equals 4 and 0, -7. All right, let's use this in our point slope formula. Y
minus, plus 7.
Because minus, right?
Yeah.
All right, so plus 7 equals
4
parentheses
x
by 0, which I'll just write as x.
Yeah.
All right. So these two equations are identical. Did you know that?
No.
What? Yeah, they're identical. So and there's like infinitely many of them. So now we're going to go ahead and transform this into slope intercept form. So you just distribute. It would be messed up if my math was wrong and they weren't identical. Okay. So we have. Go ahead. Distribute.
4x minus 12.
All right, and you give it y minus 5. So add 5 to both sides, right? And then what is the equation from here?
Y equals 4x minus 7.
Does that seem familiar? Bam! But wait a minute. Let's do this one here that looks nothing like the original one up there. All right. We'll just distribute the 4. Okay. So then you have y plus 7 minus 7 minus 7. Gone. Y equals 4x minus 7.
It's actually the same.
The same one.
Yeah.
Because that point exists on the same line as the other point. So it's always going to go. It's going to take you back to the core equation. It's going to take you back to the general equation. But these point slope answers are always going to be different because you're using different points. But once you work out the math and put them into y equals mx is b, they're always going to come to the same equation. Make sense?
Yeah.
All right. When you have something like 3x plus 5 equals 2, and I'll just do an easy one like negative 3x plus 2 equals 4, and they're like, solve for the system of linear equations using elimination.
You just eliminate the 3x.
All right, so you eliminate the 3x. Then what? Wait, there's supposed to be y's here.
Then you get 7y
7y.
and 6 equals 6.
Cool.
Then you do y equals 6 over 7.
Good. Divide by 7. Divide by 7. Y equals 6 over 7. We done?
No.
No.
You plug it back into the y,
Okay, plug it back into the y. Which one do we use?
the top equation.
Yep, and you can use either one.
Yeah.
But why start with the one with the negative? All right, so then you got 3x plus 5 times 6 over 7, okay, equals 2.
Then it becomes 30 over 7.
All right.
2. Then you can multiply the 7 to the other side
How do you do that?
because to cancel out the fraction.
So how exactly would I do that? I think you're about to get this wrong. Pressure's on.
Multiply 7
Like how? Like
to both sides.
so? Like how? Like right here? Like right here? Like I mean, like a do like a bracket and put it over here.
No.
How should I do it?
Just remove that and multiply that by 7.
Tell me what to write. What do I write where?
You multiply 7 to that.
To the 2?
Yeah.
I get 14?
Yeah.
And then I get 3x plus 30 equals 14?
Yeah.
Wrong.
Huh?
Yeah.
Why?
Oh, I'll prove you over here.
Oh, you have
So-
to multiply this by 7 as well.
Yeah. Because look, if you have... How can I prove you wrong? If you have 5... I got this. 5 plus 5 equals 10. According to what you're saying, if you multiply this by 2 and this by 2, we should still be equivalent, right? But we're not.
But,
You gotta do that.
okay.
Okay?
Yeah.
So if you want to kill your fraction, hit everything by the denominator. 7, 7, 7. And then there's y. Cool. 21x plus
30 equals 14.
good. And then minus 30 minus 30. 2x equals
21x, isn't it?
Oh yeah. Got excited. 21x equals
16.
negative 16, right?
Negative 16.
All right, negative 16. Divide by 21. Divide by 21. And that's that. All right, so we have our x value, which was 6 over 7. This is an ugly answer because I made up the problem. 6 over 7. Those are our x. And our y, so x equals that. And y equals that. Okay. What does that mean?
That means that's the x and y.
What does that mean? What do you mean x and y? Did I just graph a little dot?
It means you've solved the system of equations.
And what does that mean?
It means you got the answer.
What is the answer?
Um,
Don't say negative 16 over 21. Wait, hold on a sec. All right, so here we are on Desmos. I'm going to type in the top equation. And then you're going to tell me the formula for the second equation.
negative 3x plus 2y equals 5. 4.
4, okay.
It was 4.
4. All right. Well, you should notice something very interesting about the red line and the blue line. What do we see? What's happening?
Perpendicular.
No.
Intersection.
They're intersecting. I'm going to see what this point of intersection is. I'm curious. Huh. Let's take a picture of that. All right, so I'm going to go over here. Go over here. That's the wrong your. All right, go over here. All right, this is the point of intersection, right? And we forget our. So if we punch in 6 over 7, oh, that's a little awkward actually. Hold on. I found your mistake that you made. It's right here. You were supposed to have said this was X. And if you replay the video, we'll confirm that it was you that said that after I do some edits. Okay, so we have that. We have that. All right. So if we go over here now. All right, so let's divide 6 over 7. All right, so 6 divided by 7. Oh, wait, 0.857. Look at that. What? This is 0.857. And if we divide negative 16 over 21, guess what we're going to get? Negative 0.76. Negative 0.76. So this coordinate, I could write it because that's x, negative 0.76, comma 0.857. Now remember, back in the day, a long time ago, when I was like, hey, what's the significance of a system of linear equations? You said, to get the answer. And I said, and you're like, gives you a point. And I'm like, and?
Intersection.
The point of intersection. You find one point that the two lines have in common. And that's it. So that means that if I did, if I plug in like negative 0.76, like if I plug this in, basically if I plug in both points, one for x, one for y, into either equation, you're going to get something consistent. You're going to get like 5 equals 5. You're not going to get like 5 equals 12. Both equations work out. All right. Now, if you have a system of equations, actually, I can make one up. That's like, here, watch. Let's say I have y equals 3x plus 5. And let's say I have y equals negative 3x. Y equals positive 3x plus 10. What do these both equations have in common?
3x, same slope.
Same slope. So therefore they are
parallel.
Parallel. All right, let's see if we can put both of these equations into standard form. So in useless form. So let's go ahead.
Stupid form.
Stupid form. Okay, so let's put a stupid form. Go.
So it's going to be...
So basically bring the 3 over here.
Okay, so it's going to be 3x.
Negative 3x.
Negative 3x.
Uh-huh.
Plus y equals 5.
Uh-huh. And then, what's the other one?
Negative 3x plus y equals 10.
Mm-hmm. And technically, I believe that standard form, like, you're not allowed, it doesn't really matter for this problem. You're not allowed to have a negative in the front.
Oh, so you can change the symbol of all the other ones.
So you can multiply, yeah, exactly. Multiply both by negative 1. Mm-hmm. So then you end up with 3x minus y equals negative 5. That's the top one. What's the bottom one going to be?
The bottom one's going to be 3x minus y equals negative 10.
Equals negative 10. All right. So now, what was the relationship between these two lines?
They are parallel.
Parallel. All right. So we're going to do our system of linear equations again. Right. So we want to make sure we can wipe out a letter.
Mm-hmm.
So what do we do?
You multiply negative 1 to one of the equations.
All right. We'll do the top. So we're going to get negative 3x plus y equals positive 5. And what do we get on the bottom?
3x minus y equals negative 10.
Yeah. So 3x minus y equals negative 10. All right. Now what do we do?
Cancel out the 3x and cancel out the y.
Oh. So then you end up with 0 equals negative 5. So whenever you get that, you know you have parallel lines. 5 equals 14. 3 equals 2. Is that even true?
That means parallel.
That means parallel.
Why?
Because it didn't work. It didn't. You were unable to solve for a letter. So basically, when x and y wipe out like that, you have yourself, or not even when they wipe out. If you end up with like a 7 equals 12, you got parallel. When you get like one thing equals one thing that it's not,
That's parallel.
that's parallel.
Okay.
Okay, so
basically, if it doesn't make sense, it's parallel.
yeah, if you're like, what the heck? You're like, what? This was wipe out. But look at this. You could end up with a line like this. That's like 2x plus 4y equals 16, and negative 6. Why would I do that to myself? Negative 2x minus 8y equals negative 32. All right, let's do a system on this situation right here. Wait, so this is... All right. So...
Just cancel out the 2's.
All right, let's cancel the 2's. Bam.
Then becomes negative 4y.
Negative 4y.
And negative 16 equals negative 16.
Wait, this is a poorly designed problem. Hold on, I messed up. Okay. Right here. Associate 4 right here. There. Now we're ready to go.
Are you trying to make it parallel?
No.
Well, it's going to equal 0.
Where? Like how? What do you mean?
If you multiply this by 2 at the top part.
So if I put top by 2, what's going to happen?
The whole thing's just 0.
So you get 4x plus 8y equals 32. And negative 4x minus 8y equals negative 32.
Yeah.
And what you just said is like that?
Yeah.
Okay. That means, wait, what? So that's one line, that's another line, right?
No, it's the same line.
It's the same line. How many solutions do they have?
Infinite.
Man, you're smart. Yeah, infinite. They have every point in common, right? How many points do these guys have in common?
1.
0. Parallel lines don't have any points in common because they're parallel. They don't intersect.
Yeah, so they have 0 points in common.
0 points in common.
Oh.
And then here, you said 1 though.
Oh, yeah. There.
So, and then if you actually can solve for x and you actually can solve for y, how many points in common do you have?
2.
Well, I think you're thinking the right thing, but saying the wrong thing. You have 1 point in common, x and y. Like,
Yeah.
right? Like,
Oh!
right?
Yeah.
You have 1 point. Okay. So that's how that works. So, so a harder problem that the College Board will ask you will be something like this. Let's see. We have 3x plus 2y equals 5, and 4x plus 6y equals 10. I'm just kidding about one of those letters. I'll put a K right there. Okay. And it'll say, solve for K such that the two lines are parallel. And
How would you do that?
it might not even stack them, by the way. It might say equation 1 has this equation, equation 2 has this equation. Like, so it doesn't even give you the hint to stack them. So it says solve for K so that the two lines are parallel, right? All right, so, but we know something about parallel lines. What do we know?
That they will not equal.
That's true. What do we know about their slopes?
Same.
The same slope, right? But when they're written in standard form like this, you don't. It's not necessarily
So change it back.
easy to see the slope. So change it back, right? So we'll get this one here. I'm going to rewrite it just to waste time. Ky equals 5. All right, change it back. So you want to put this into y equals mx plus b.
So
How do we do that?
y equals negative 3x plus 5 over k.
All over k?
Yes.
Let's see if you're right here. So we have, So you have minus 3x minus 3x. So you have k y equals negative 3x plus 5. You are right, Mr. Good Working Memory. Okay, that's good. All right, so I'm going to rewrite that as y equals negative 3 over k x plus what?
5 over k.
Good. All right. And now let's do the other one. All right, so we have 4x plus 6y equals 10. Okay, go.
It's going to equal y equals negative 4x over 6. Oh, plus 10 over 6.
Minus 4x and minus 4x. And 6y equals negative 4x plus 10. Minus 6, minus 6. You are right. Split it up.
It's going to be negative 2 over 3x plus 5 over 3.
Cool. And now we can do this problem, actually. So we're going to compare this equation with this equation. And in order for them to be parallel, what must be the same?
The two equations, so you make them equal to each other.
Not the equations, only one component in the equation.
The slope.
The slope. So where's the slope in the first yellow equation?
This one?
Mm-hmm. What's
So
the slope?
Negative 3 over k
Mhm.
x.
No, just negative 3 over k. Because it's mx. So m is the slope. So negative 3 over k has to be equal to what?
Negative 2 over 3.
Negative 2 over 3. All right, so how do we solve?
You
The easiest way to solve.
Oh, you do the cross multiply?
Cross multiply, yeah, good. Only with equal signs in the middle.
Mm-hmm.
Go ahead.
So it's going to be negative 9 over...
Equals.
Oh, equals...
So that times that equals that times that.
Mm-hmm.
Okay.
Equals negative 2k.
Good. We can flip it as 2k equals 9 if we want. Okay.
Mm-hmm. Then you divide by 2, so k is equal to 9 over 2.
There. So that would fall into definitely probably the harder category.
Mm-hmm.
Sorry, I see those quite often. All right. Do you have any questions about linear equations?
I think I understand it better.
Yeah?
Yeah.
Good. The only thing I think left out is substitution. Do you know what substitution is?
Like plugging in numbers for like random numbers.
Well, we could do an awful problem, which would be... I think it would be an awful problem. It would be this one. This one here. So this one, what method did we use to find the solution? What method was used?
Substitution.
Nope, we used elimination. So right here, we eliminated x. X is gone, right?
Yep.
It's also called linear combination. Some textbooks call it elimination, others call it linear combination. So you have, I'm going to write down the two equations again. So you got 3x plus 5y equals 2, and negative 3x plus 2y equals 4. All right, so the other way you can solve for this is through substitution, which I hate. I really think this world could be divided into two types of people. It's not race, it's not income, it's whether you like substitution or elimination. That's it.
What do you like better?
I like elimination. I'm an eliminator for sure. Not religion. That's all insignificant. Hold on a second. All right. So, but you have to know how to substitute, though. So, you can get the same answer. So, do you know how to substitute?
Yeah.
Okay, how do you do it?
You change one to a different form.
Okay, so I'm going to go ahead and, with this top one right here, I'm going to write it as 5y. Let's throw the 3x to the other side. So, what are we going to get?
Negative 3x plus 2
3x plus 2. All right, divide.
over 5.
So divide by 5, divide by 5. Y equals negative 3x. I'm going to actually split it. So y equals a negative 3x over 5 plus 2 over 5.
Then you could plug in that for y.
Yeah, I'm actually not going to split it. I think it was easier the other way. Really? Wait, did I just like pass the split? Wait. Oh, I see what I did. Here's the negative 3x plus 2 over 5. All right, and you plug it in where?
To the other equation's y.
Good. So negative 3x plus 2 parentheses negative 3x plus 2 over 5 close parentheses. All right?
Seems more complicated.
Yeah, that's why I'm not part of this group. Okay. But there are some problems where it is easier to substitute. Now with like fractions and stuff. This is awful. Okay, so now what?
Equals 4.
Oh, yeah. Equals 4. Okay.
And you distribute the 2.
All right, what do we get?
You get negative 6x plus 4 over 5. Then, like last time, to remove the denominator, you multiply 5 to everything.
Yes. Just this one on that one.
No, and the other one.
5, 5, 5. All right.
It becomes negative 15x and negative 6x
Minus 6x
plus 4
plus 4
equals 20.
All right.
That becomes negative 21 plus 4 equals 20. Then negative 21x equals 16. And x equals negative 16 over 21.
Did we get that before? It just looks kind of familiar. Cool. Right?
Yeah.
Then you got to plug that back in to get the other one,
Yeah.
right? Which we're not going to do. So that's pretty much it. All right. Any questions? All right. Say bye to your future self.
Bye.